Good morning, dear students. Welcome back to your another session of your online classes. Children, we were discussing about lesson number 8, motion. Today is the 8th part and the concluding part of the lesson. Today I am going to take a very small topic. Let us begin with the topic for today, uniform circular motion. Uniform motion, children, I hope you remember the definition. So what is uniform circular motion? When a body travels equal distance in equal interval of time over a circular path, then the motion of the body is said to be in circular path. The direction of motion at any instant of time is along the tangent to the circular path at that instant. Means at any particular point we try to stop the body, the direction of movement of the body will be tangent to the circular path. Now children, what is meant by tangent? It's a word that you must have studied in your geometry when you were studying about the circles. Now children, you know circle. It has got a circumference. So any particular point which touches to the circle is called as a tangent. It should be understood that in uniform circular motion, the speed of the body always remains the constant because we are talking about uniform motion. But it must be remembered, children, that the direction of the body keeps on changing continuously. See, this in this particular figure, children, can you see the red color arrow? Yes, they are the tangent. I've just taken a very simple diagram, children, and at any particular 4 points, you stop the body will move in the same direction where the red arrow is pointing. Okay, and this will be called as tangential movement, right? Children, to experience this, you can do a very small activity at your home. See to that you don't hurt anyone. Take a pencil or a small uh, eraser. Take a small piece of eraser, tie it with a thread and move it slowly. Right? When it acquires a uniform circular motion, just leave the thread and you will find that it goes exactly in the tangential direction where you stopped. Now, uniform circular motion is an accelerated motion. When you were moving the eraser, children, with the thread, you had to continuously apply the force so that the direction is changed continuously. Okay, and children, when a body is moving in a uniform circular motion, there is also an external force. This external force can be applied in any way, like when you were doing it moving with the eraser, you were applying that external force with your hands. So whenever a body is moving in a uniform circular motion, there has to be an external force, okay, so that the body continuously moves in a uniform circular motion. This force is called as the centripetal force. Now children, how do we calculate the uniform circular motion? Because here, how to find the u, how to find the v. So let us find the equation to calculate uniform circular motion. Let us consider that r, small r, represents the radius of the circular path. T is the time taken by the body to complete one round of the circle. V is the speed of the body in a uniform circular motion. So children, the distance travelled by the body to complete one revolution will be equal to the circumference of the circle. Again, circumference of the circle is a concept that you have studied in your maths, geometry. So, distance is represented by S. So, S is equal to 2 pi r. Right? 2 means, I think children you remember this formula 2 pi r. Pi is, the value of pi is either taken as 22 upon 7 or 3.14. Right? We know the formula, children. Speed is equal to distance upon time. So what is the distance here? 2 pi r, and what was the time that we have assumed as t. So how do we calculate? uniform circular motion of a body by using a formula 2 pi r upon t. Children, let us understand, let us go through some of the very common example of uniform circular motion in our day-to-day life. A piece of stone tied to a thread and rotated in a uniform circular motion, right? Now children, sports day, I hope you remember. Now children, during sports day, we have many events and some of the events are hammer and discus throw. Now before the athlete throws the hammer or the discus, right? He takes that particular thing in his hand and gives a circular motion to the hammer or the disc by rotating his own body so that it takes a very good distance. Some of the very common examples are, children, you know that our moon continuously shows a uniform motion across our earth. Okay, same way our earth is continuously showing uniform circular motion around the sun. The various artificial satellites which are there around the earth, they are also exhibiting uniform circular motion. Now children, the watch, the clock that you have, it may have three hand or two hand, but all of them show the uniform circular motion. So children, this was all about the today's topic. I hope you enjoyed and understood your lesson number 8. It's a bit new concept for you children, but please go through the concept. Please write down all the notes that I am giving you in the PowerPoint presentation. So and try to understand them, try to learn the definition, try to learn the derivations. In case you don't understand, please give me the feedback on my email address. And now children, tomorrow I'll be taking some of the numericals for this lesson, and few I will be solving and few I will be giving you as your homework. In case you don't understand, please give me your feedback. Thank you for today's topic. I hope